let's go ahead and start with where we're here, where we are. Okay, we'll do some problems, and I'll let you guys do some problems. Okay, so what we're learning how to solve is what we call an exponential equation. And an example of an exponential equation is just something like if you got 2 to the x equals 8. Sometimes an exponential equation is super easy, like in this case, the answer is 3 because 2 to the third is equal to 8. Sometimes you can do them in your head. Most of the time you can't do them in your head, so you have to learn a process to get you to that point then, okay? All right, so these are just kind of the steps that we're going to generally take on this. And let me kind of run through just a couple of these things right here, all right? This is an example of one that you could do in your head. If you can't do it in your head, you can use your calculator to find out. You can just sort of do trial and error. If you did 4 to the second, for instance, that's 16, so that's definitely not the answer. So what do you raise 4 to get 64? Do you know that without using your calculator? 3. Not the 4. 4 to the fourth is 256. Okay. So what you're going to find on this is if you plug in a 3, and you can use your calculator if you need to, you get 64. So you get x equals 3. You can do that in your head. I'm going to show you a strategy in case you can't do it in your head, okay, because sometimes you can't do it in your head. So here's what you can also do. This is an alternative way to doing this. You could write 4 as 2 to the second, and then you still have the x. You can take 64, and you can write that as 2 to the sixth power. And again, you just have to kind of play with your calculator a little bit if you don't know those things, okay? So what you would get is you would get 2 to the 2x, because you multiply those exponents. And then if you wanted to do it this way, you want to try to do it in your head if you can, of course, but the idea is if these bases are the same, then so are the exponents. So that's kind of what we're going to be looking at. You're going to see me do this over and over again. If these two bases can be made the same, that's what I mean by the bases, then the exponents have to be equal. So what you do to finish the problem up is you have 2x equals 6. Then you can divide both sides by 2, so you get x equals 3. Okay, I wouldn't do that problem that way because I can do it in my head, but we're going to probably, this next equation that I'm going to look at, this example 10, you're not going to have any choice but to do it this way. Okay, all right, so let me kind of show you what I'm going to be looking at in this next problem. I designed these problems so that they can be done this way too. So the idea that you want to get established in your head here is that base is 2. Is there any way we can make 8 a power of 2? Do you know what you raise 2 to get 8? What? Third power. Third power. Good. So you want to write this first step like this. Bring this down and write this as 2 to the 1 plus 2x, and then write this as 2 to the third power like that. Okay? So again, what I'm doing on this, if these bases are the same, here's the question. What can you conclude about this problem? If these bases are the same, what do you conclude about the exponents? They're also the same, exactly. That should be logical to you, hopefully. So what that means is, what we would do is you just set the exponents equal to each other now. Now you got a super easy equation to solve, see, okay? So I think everybody would be able to do this. Okay, you subtract 1 from both sides. That gives 2x equals 2. Then, of course, you can divide by 2. So you get the answer of that problem, x equals 1. Okay? That's how you can put that problem together, is by doing that. Okay? Now, we're going to check these because that ultimately helps you understand what you're doing. How do you check any equation? Well, you plug the answer in to the original and see if it works. So just write down the original. You're going to have 2 to the 1 plus 2 times 1. Just replace x with 1, and then work this out. Well, that would be 2 to the 1 plus 2. So that's 2 to the third. What is 2 to the third? 8, right? That's what it's supposed to be. Okay, so see, it checked out. It turned out that that's equal to what it's supposed to be like that then. Okay, I need to kind of move this over a little bit so it's not interfering with what I wrote on the board. Okay, so see what I did, and I had to design the problem this way. I've had a 7 instead of an 8. You can't do it this way. I purposely put a number that could be expressed as a power of 2. Does that make sense to you, what I'm doing? Okay, so like I said, if the bases are the same, so are the exponents. That's what you conclude, okay? Okay, they're going to kind of do a couple of levels of these problems. I'm going to give you guys a little bit of time to work on number 11, 12, and 13. You probably could do 11 in your head. You're going to need probably a calculator, maybe particularly on this next one. And then 13, you may or may not need a calculator. So I want to kind of see what you all can do with this and see if you're understanding what I'm trying to show you here. And I'll come around and give you a little help, but give it a shot. Okay, so I think we're looking okay on this one. This one you could do in your head, or you could write this as 5 to the x equals 5 to the third. And like I said, if the bases are the same, then so are the exponents. So the answer, that's x to the third. If you can do that in your x equals 3, if you can do it in your head, do it in your head, okay? All right? The next one went like this. You would have 4 to the 7x. And what I did is I just took my calculator and kind of experimented until I found the one that worked. So if I just go like 4 to the 5th, that's what gives you 1,024. So I just wrote that as 4 to the 5th, okay? Now that means the exponents have to be equal. So we have 7x equals 5, divide by 7. So everybody, I think on that one, I think we're getting 5/7 on that. Okay, right? Okay, and then the next one, let's see, we have 4 to the 1 plus 2x. What did you all do with the 64? Set it as equal to 4 to the third. Good. That's the whole point. Now the exponents have to be the same. I think that's the same problem I did a minute ago, or I did something awfully similar to it, I think. Okay, so what you do is just subtract 1. You get 2x equals 2, and then you can divide both sides by 2. So you end up getting x equals 1. Okay? So if you could do something that way, then you can do it. What we're going to focus on mostly is an exponential equation where you have to use logarithms. Okay? So if you have to be pretty well adept with your logarithms. That's what we've been working on the last couple of weeks. Okay, so let's go down to this example 14, and this is totally different. The idea on this problem is, you can't do anything with that 19. 3 to the second's 9. 3 to the third is 27. You can't make that 19 a power of 3. So your only choice on these problems is to use logarithms, and you're going to have to do kind of what we were talking about in class, on Tuesday. I'm a little concerned some people may not been doing much with the homework on the logarithms, so you've got a lot to learn. So you can either take a base 10 log of both sides or a base e. Okay, now we talked about that on your calculator. Your calculator does an log, which is a base 10. It does a base e, which is an ln. Take your pick. I'm going to pretty well just, on this one, I'm going to choose to use base 10, but it's totally up to you. So go ahead in your first step, just take the log of both sides. That's something that we talked about last class, is you can take a log of both sides, okay? All right. And then what we learned is that there's a property of logs that says if you have a log of something to a power, you can bring that power down in front, okay? So we would have x minus 1 times log 3 equals log 19 like that, okay? Now, you can do these problems with, you at least have to know that property, that thing can come down in front of a log. Now, what you want to do is you want to get x by itself, and you're not going to do anything on your calculator till the very end of the problem. You can't do log 3 and log 19 unless you use your calculator. So what I'd recommend you do is just divide both sides by log 3. Log 3 is a number, okay, so you can make it go away. So now what you have is you have x minus 1 is equal to the log 19 over log 3 like that, okay? Now I got one more step, and then x is by itself. So what do I need to do to both sides of this equation to get x by itself now? Add 1, good, thank you. Okay, so we add 1, okay? So you would just, and then you would have to go to your calculator. So what we would have from here is we would have x equals, and then you would have log 19 over log 3 plus 1. Now that is the exact answer to that problem. we want to go ahead and use our calculator to get the approximate answer also. Okay, so the problems we're going to be focusing on here for a little bit are going to be working with logarithms. So now take your calculator, and you have to put this in kind of carefully like this. You just put in log the base 10 of 19. Be sure you close your parentheses. Then divide by log 3 like that, and then put plus 1. Okay, and then we're going to round this off to 2 decimals. Okay, so we end up getting about 3.68. If we round that off to 2 decimals, that would be the answer to that problem, a rounded answer like that. So all I really did was this. I did a log of both sides, and then we learned last class that you can bring that exponent down in front like that. Okay, now let's find out why this is right. Okay, so when you check your answer, you want to go back to the original problem. The original problem is 3 to the x minus 1 equals 19. Just plug that back in for x, and we'll use our calculator to see if this is right. So we'd have 3 to the 3.68 minus 1. That is 3 to the 2.68. Let's see if that's 19 or real close to it. Okay, so if I go through and now just do 3 raised to the 2.68 power, look at that. That's about 18.99, so it's close enough. The reason it's not perfect is because, I had to round on that. So that's the idea. So these kind of problems right here, a lot of times you're going to be getting decimal answers on that. Okay, do you guys understand what I did? By taking log of both sides? Okay, can't do these in your head. These are not as easy as the ones I just had you do a few minutes ago. Okay, the next question is the same idea. Your variable is in the exponent. That's why we call that an exponential equation. So you can either take the log of both sides, or you can take ln. You are better to use ln on this problem. Okay, and the reason is because a natural logarithm, ln, is a base e. So what we're going to do a little bit differently on this problem is we're going to do ln. Now, I could have taken the ln of both sides of the last problem and got exactly the same answer. Okay, so start that way. Okay, we're going to start that problem the same way. Okay, what do I need to do next? What did I do in the last problem? I brought that down, right? The exponent comes down in front. The entire exponent needs to come down in front. So you're going to get x plus 3 times ln e equals ln 6. Okay, like that. Okay. Now, you can do anything you want to on the calculator. You can do ln of e, and we've learned that ln of e is 1 anyway. So if I did ln of e, and see that e is above the division symbol. So if you're kind of new to that, if I go second division symbol, that's how I do ln of e, and that gives 1 anyway, see. Okay, so I get x plus 3 times 1, that just is 1, is equal to ln 6 like that. Okay, one last step and I'm done. So what do I do to both sides to get x by itself now? How do I get rid of plus 3? Subtract 3, right? Okay, so what I'm going to do is I'm going to subtract 3. Okay, like this. Okay, so I've got that. So I've got x equals, and you're better off to write this as negative 3 plus ln 6 like that. That is your exact answer to that problem. We're going to go to the calculator and get something, get an approximate answer to it. Yeah, Daniel.
Why is ln e not input as 1 and then added to it?
So when you multiply something by 1, nothing changes. So think of it this way. Really, it's x plus 3 times 1. I just didn't show that step, but it might help if you do. Okay. Right. Now take the calculator and just plug it in. Okay. So if you go negative 3 plus ln of 6 like this, and then this will give us an approximate answer of negative 1 point, and then we're going to use 2 decimals, so round that negative 0.20 to negative 1.21 like that. Okay, so that'd be the answer problem. Both those problems were done the same way. Okay, you want to use the ln of both sides when you have a base of e. Makes the problem a little bit easier if you do. Okay, so let's go ahead and let's check this one too. So just write the original problem, e to the x plus 3. We're trying to see if that's equal to 6. You got to use your calculator to check it. So replace x with negative 1.21. Okay, if you take this, and you can do this all in one step on your calculator and just do this like this. Now, one thing that you want to kind of get familiar with is this ln button. Above that, it says e to a power. So what you can do is you can go like this. You can go second ln so that e comes up. Then you just put in the negative 1.21 plus 3, or you could work out the negative 2.1 times 3 earlier in the problem if you want to. So that's like about 5.989. That's close to 6. And that's what it was supposed to be, was it was supposed to be 6. Okay? So I'm doing log of both sides. The purpose of doing log of both sides is this. That's what allows that thing to come down. Does that make sense to you? Okay? All right? Okay. Now these things right here, you use this a lot in economics and when you're working like with compound interest formula and stuff like that we've talked about. Okay, so I'm going to let you all try two problems and see what you do. Okay, on the next page, 16. And just on both of these problems, you can do the ln of both sides, or you can do the log of both sides. It doesn't matter which you choose to do. Okay, still going to work, so take your pick. Okay, but you're going to start each problem by doing log of both sides and then just kind of see what you can do. You're going to need to use your calculator. Try to round your answers to 3 decimal places. Okay, so yeah, this one, when you do the log of both sides, and everybody did log base 10, it doesn't matter which one you do, you're going to take the log of both sides on this problem. And you got to write steps correctly. Now you'd bring the x down. So you have x times log 3.3 equals log 45. Okay, then you can divide by the log of 3.3 because it's a number, just a standard equation like we've been solving for a long time this semester. Okay, so we get x equals, and that's just a matter of doing this on your calculator. Be sure, when you do your calculator, be sure you enclose things in parentheses. So I'm going to do log 45, make sure those parentheses are closed before you divide, and then log 3.3, like that, then we can round that off. Okay, so that one was 3.188 if you rounded to 3 decimals. Everybody got that one okay? All right. Now, let me show you where I think a lot of you are going wrong on the next one is by doing this. You can go ahead and do the log of both sides. And don't try to, skip steps when you're first learning this. So we start that way, okay? And then what happens is the x plus 6 is an exponent. It comes down in front of the log. So does the x. I saw several of you forget about the x on the right side of that. So what you get is parentheses. That's a mistake that I saw several people make. You have to have x plus 6 in parentheses because it has 2 terms. Times log 6 equals x times log 7 like that. Okay? All right? Make sure if you don't have parentheses around x plus 6, you need to do that now and get that in there. Now, what I would suggest that you do, you could, if you wanted to, you could certainly divide by a logarithm. I think you would probably do the problem better if you just went through and just did on your calculator the log of 6 and changed it to 3 decimals. So I'm going to write this like x plus 6 times, and then the log of 6 is 0.778. Let's just do that. Then I'm going to take the log of 7, and that will give x times 0.845 like that. Okay, because you can do the decimals earlier in the problem if you want to. Now what I'm going to do is I'm going to do a distributive property. Okay, so when I do that, I'm going to have 0.778x. Then I'm going to take the 0.778 times 6. Whoops, I think I got an extra decimal in there. So I'm going to do 0.778 times 6. Okay, that'll give me plus 4.668, like that. And then this side right here will be 0.845x. You guys see what I did? This is my calculator. Okay, and then I did a distributive property. That's where I think a lot of you are messing up. Now I need to get x's on one side, so I'm going to do this. I'm going to subtract 0.778 from both sides, like that. Okay, that's going to give me this. That's going to give me 4.668 equals. Okay, then I'm going to take my calculator and I'll do that. I'll do 0.845 minus 0.778. Okay, that'll give 0.067x. It's kind of looking like I might get a different answer when I was working it out. Okay, then I'm going to divide by 0.67. Okay, and let's see what I get. So I got 4.668. Yeah. 668, and then divide by 0.067. That gets this. Okay, so I get, and I think, yeah, that's what I got when I did that before. So final answer is 69.672 is equal to x. Did anybody end up getting that? Just now. Okay, all right. So, I mean, sometimes it's good to just, once you get the log in the problem, just use decimals. And then that is a standard equation at that point then. Okay, you guys understand what I did? Okay. All right. Okay, now a couple other things to kind of wrap this up. I want to get this section wrapped up, and then we're going to do the circles and kind of talk about that today, because that's something you'll see on your final exam. So this problem right here, you have a formula that we've seen before, this kind of population formula. It says T is the amount of time after 1998. And the question is, when will the population reach 293,000? So what we're going to do on this is A is the population. So you're going to replace that A with 293. Okay, and we're just going to leave that as 293. We're not going to put in 293,000. We're just going to do that. Okay, and then we're going to let that be equal to 235 e to the 0.044 t. So we're going to find what value of t makes the 235 grow to 293. This is your initial population. 235,000 in a certain amount of time, that grows to this. Okay, so we're going to solve this equation. You have to use logarithms to do this. You don't want to take a logarithm unless the e is by itself. So this part of the problem right here needs to be by itself before you do the log of both sides. So what do I need to do to get rid of that 235, you think? I want 235 to be there. How can I make it go away? Divide. There you go. Thank you. So we got 235. I like that. So we start that way. Now you could take your calculator and take 293 divided by 235 if you want to. I'm going to choose not to do that, but that's your call. If you want to get decimals now, you can. What I try to do as much of my calculator work at the very end of the problem. Okay, now I'm going to take ln of both sides. All right, well, let me ask a question and see if you caught on to this. Why did I take ln of both sides instead of log of both sides? Because that's an e. Okay, that makes it easier. Okay, all right, now what have we been doing with the exponent? What am I going to do with that 0.044 thing? I can now bring it down. Okay, that's the right reason logarithms are helpful to us. So we get ln 293 over 235 equals 0.044t times ln of e. Okay, so we got that. Okay, what's ln e? That popped up one time in class today. Thank you, 1. And if you forget that, you can use your calculator. So that thing is equal to 1. So you really get ln 293 over 235 is equal to 0.044t. One more step and then I'm done. So now it's standard equation. What do I need to do to get t by itself now? Divide. Okay, got to divide. Good. Okay. So we need to divide by the 0.044. Okay, that will get t by itself on the side like we wanted. And then we have to just go to the calculator. Okay, because you do want to go to the calculator on this and get a approximate answer. And you can do this in one step. You can go natural logarithm 293 divided by 235. Make sure you close parentheses. Divide by 0.044. And that will give about 5.01 years. So I'm just going to round it like to 2 decimals. So the final answer on that problem would be about 5.01 years is how long it takes for that population of 235,000 to grow to 293,000. Okay, that's a typical exponential equation, typical kind of application that we use for logarithms. Okay. All right, any questions about what it did? Okay, let me ask a question. How would you as a student know that you would have to use logarithms to solve an equation? It all depends on where the variable is. Where does the variable have to be if you're going to use logarithms of both sides? It has to be in the exponent. That's what we're doing. And the purpose of doing a logarithm is that it brings that unknown out of the exponent. That's why. That's why you do that, see? Okay? Okay, so I'm going to go through these next two problems here. And these two problems right here are a little bit different idea. All right, so these right here, you're not going to take logs of both sides on this. These things are going to look a lot like a factoring problem. So the first thing we're going to do is we're going to get one side equal to 0. So you want to write down that you have e to the x plus e to the negative x minus 6 is equal to 0 like that. Okay, we're going to try to do that. Now, what I'm going to show you all on these problems is I'm going to show you how to use your graphing calculator to solve these. If we had a little more time, I'd show you another technique of using this, but I'm just going to show you how to solve this problem on your graphing calculator, both of these problems. Okay, so get your calculator out, and let me show you what we're going to do on this then. So what you want to do is you basically just go to y equals, and you put in the left side of that equation. Just put it in. So go, put in e to the x like that. Bring that down and then put plus e to the negative x. Okay, then minus 6 like that. And then just graph it in a standard window. Okay, so once I get that put in, just go zoom 6, put it in a standard window. And here's what happens. Now, in that particular graph, how many times does this graph cross the x-axis? Twice, exactly. And that's what we're going to end up looking for is those two things right there. Okay? So when I put this together, what we're going to do is we need to figure out what these two x values right there are. Okay? Because that's where the function's equal to 0. Okay, so let me show you how you do that now. You don't estimate it, you do a 0 command. And I've taught you how to do this before when we were talking about zeros of polynomials. Okay, so write the keystrokes down if you need to. What you would do is go second, type your second button, and then trace, and then find the option that says 0. Okay, you're going to do option 2, which is a 0. Okay, press enter once you see that. Okay, now what it's going to do is it's going to ask for a left bound. So what I'm going to do is take my left cursor key right here, this left arrow, and I'm going to move that until it's on the left side of that intercept. That x-intercept's right there. Okay, once you get it there, once it asks for left bound, set it and then press enter again. Okay, like this. So you just go like that. Okay, usually what happens is a line comes up on your calculator. Then it's asking for a right bound. So now use your right cursor key to go a little bit to the right, then press enter for that right bound. Okay, you guys with me and what I'm doing? I'll do it another time on this next one. Now it's going to say guess. And when we do guess on this, okay, just press enter. Okay, so if you following all this, press enter, it's going to give you that 0. So that 0 is negative 1.76247. Okay, that's the answer to that equation. That's one of the answers to that equation. And see, the thing is y equals 0. That's why we set one side of that equation equal to 0. Okay, now I'm going to do this again. I have to get the other answer. So just follow these keystrokes again, start over again. So go second, trace, option 2, press enter. Okay, get your left bound set up. Now I'm doing the x-intercept on the right, so just make sure your cursor is a little bit to the left of that intercept. Okay, it doesn't have to be super close to it. Just get it relatively close, press enter. Now right bound, move the right cursor a little bit to the right, press enter again. When it says guess, press enter again, and then that second one's going to come out. So that one is positive 1.762, and I'll just round it off. Let's see, or I'll just put all these in there, 7472. So that's how you do that. You can solve an equation, any equation on a calculator. Okay, if something's graphable. Okay, did that make sense what I was doing? Okay, I'm going to have you all just try this second one here. First thing that you want to go ahead and do is just move the one to the left side and then put it in your graphing calculator and we'll kind of see what you all get on that. Just see if you can solve this with a graphing calculator. That's good enough. When I put this one in the calculator, it looks like it only crosses one time. Okay, Charles' graph kind of looked like this when you put it in. What's wrong? I think my calculator just crashed. What'd you get? Did we get anything on that one? You got what? 0.48?
3862.44.
Okay. Let me just make sure. I think my calculator just decided to crash on me here. Yeah, it intercepts one time, so 1.3862 approximately. Is that what you said? Okay. All right. That one's pretty easy to do. I don't know why my calculator sometimes just crashes and I have to reboot it. So I'll do that during break. Okay. So, yeah, I got on that one, about 1.386294 is what I got. You can round to whatever you want to round to. Okay. All right. Let's take a 10-minute break. When you come back, we'll do the circle handout that's in the back of the class. Okay.